Today we're going to use scientific notation. It is a way of writing huge or very tiny numbers using powers of 10, which brings the exponent concept back into what we're doing. So we're going to first review scientific notation, try writing in it, or taking scientific notation to standard form. So here is the model for scientific notation. C times 10 to the n. So it's always got this, it most always has an x where you see multiplication, which is something we haven't been using, right? And that's because it's typically used in science when people are gathering data. They know that every number that they're getting, there's no variable there, it's multiplication, okay? So what do we have to remember with scientific notation when it comes to the c, this term here, that is being multiplied by the power of 10? C must be what type of number? Do you remember? It must be, Madeline says, a decimal, and exactly what though? There's a requirement for it. It has to be a what? This is the power of 10. 10 to the n is the power of 10. This number has to be a number between what?
1 and 10.
Very good, 1 and 10. And it could equal 1, so C may be greater than or equal to 1, but it must be less than 10. So it must be a single digit number or a fraction, right? Like 1.954 or something, right? 9.382, but never 10 point something. Never a two-digit number followed by a fraction, okay? That's the requirement. So the first thing we'll review is writing numbers in scientific notation. We have a really big number. So we will, and this number is in standard form. We're going to rewrite it in scientific notation. To do that, we've got to take this number and change it to a number between 1 and 10, right? And how do we do that, Matthew?
I change it to 2.675.
Okay, so he's putting a decimal right here. But where was the decimal in the original number? Way down here, right? So we're taking this huge number and we're making it a smaller number, right? By moving this 1, 2, 3, 4, 5, 6, 7, 8 times. We moved this 8 place values, right? And we ended up with 2.675 followed by 0, so we can leave them off, right? Times 10. If you're taking away 8 place values, then we add them back here. When you take away place values, our system is built on powers of 10. So we give back 8 place values by multiplying by 10 to the 8. Okay? We can do a similar thing with a really tiny number. This number is 486, and then we have to name it by naming this last place value. Who can name this last place value? Hank? So we would say tenths, hundredths, thousandths, 10,000ths, 100,000ths, millions. There it is, millions. So you would say 486 and then name the place value millions. Okay? So how do we change this to a number between 1 and 10? Haley? Good, move it to the right. 1, 2, 3, 4. Right there. We end up with 4.86. Now we gave this 4 place values, right? We made this bigger. So what are we going to do with our power of 10? Take it away. Good. Make it negative. Negative 4. Okay?
Do you have to change it to 1 to 10?
So we don't change 10 to the negative 4 to 1 over 10 to the 4. That's a great question. We did that when simplifying our polynomials that we were doing, our monomials, right? But in this scientific notation, we expect to see powers of 10 that are either positive or negative. Okay? We leave them as is. So let's go ahead and do the reverse of what we were just doing. If you receive a number in scientific notation, can you convert it to standard form? Okay, so the power of 10 is telling you how many place values you are either going to give or take away from the number that precedes it, right? So how will we do this, Tom? Good, we're going to give it 1, 2, 3, 4, and one more, right? So we'll fill with a 0. So our new number is 702,340. Good. Same would be true, or something similar, right? When we have a negative. But rather than giving this C place value, we're going to be, again, taking away. Okay? So how many place values, Kate, how many place values will we be taking away from this one?
I'm confused.
Look at the power of 10. Look at the exponent.
6.
It tells you you're going to move the decimal 6 places. Which direction?
To the right.
If you move it to the right, you're making the number
Oh,
bigger.
left.
So we're moving it to the left. So I like to rewrite this number that's in the C position, right? And now we'll take away 6. 1, 2, 3, 4, 5, 6. And fill these place values with 0. If I also fill the ones place with a 0, how many zeros do I have? 6, which matches my exponent, which is kind of a nice little rule of thumb, right? If you don't add this 0 in the ones place, you'll end up with 1 less than your exponent. Okay? Just a little detail. So we have a couple of GP to practice. Let's try again putting this into scientific notation. And this one, putting it into standard form. Okay, so don't forget to pause the video and try these and come back and check your work, right? Okay, ordering numbers in scientific notation. First, when you're ordering numbers, you want them to be in the same form, right? So here's a list of 3 numbers. They're not in the same form. So we want to change them all either to standard or to scientific notation in order to find least to greatest order. Let's change these to scientific notation to do that. Pause the video and do that and come on back. Okay, so place them in scientific notation and we compare the power. This power is greatest, so it's the greatest one, third one. And then these have the same power, so we choose the smaller one to be first. 9.028 is smaller than 9.2. Okay, in here, now you're going to apply the operations that you've already learned to scientific notation. So what does this squaring tell you that you're doing with 1.3 times 10 to the negative 5th? It feels like distributing it. So we end up with 1.3 squared times 10 to the
Negative 10.
negative 10. Good. So it has the right form, but we need to change 1.3 squared, which is 1.69 times 10 to the negative 10. Well, 13 squared is a common square. Okay. Now here we have division. Listen, look. We have division. So again, these are just 2 factors on top of each other and another 2 factors on top of each other. So we will divide those that are alike. So what is 45 divided by 15? 3 times. And then what is 10 to the 5th divided by 10 to the negative 2? Minus negative 2 is really adding 2, right? 10 to the 7th. Be careful with the negative exponent using what you've learned already, okay? How about this? If you have the product of 2, scientific notation, what? Well, you have the product of 2 things that are written in scientific notation. It's just 4 different factors, right? We have 1.1 times 10 to the 7th times 4.2 times 10 squared. Excuse me. So we could just take these 2 factors, right? And what is 10 to the 7th times 10 to the 2nd? And then we multiply these 2 factors. And what is 4.2 times 1.1? Do you know? So we have 4.62. So it's in scientific notation. Watch out. If this number said 46.2, that would not be scientific notation. You would have to take away a place value and add it back up here. Okay? And there's your assignment today.